A particle in one dimension is in a potential V of x equal to A delta of x minus A. That means it will form the delta constant potential at x equal to A. It is peaking at x equal to A. These are the minus epsilon plus epsilons are small quantity around this potential. The limit. Its wave function psi of x is continuous everywhere. Oh yeah, wave function it is continuous we know. The discontinuity and d psi by dx at x equal to A. At x equal to A, it is spiking up. That means it is goes to infinity. The discontinuity exactly arises here at x equal to A. They are asking what is the d psi by dx at x equal to A. Straightforward, we can use the time independent Schrödinger equation that earlier. That equation is given by minus h square by 2m d square by psi by dx square plus v psi equal to e psi minus h square by 2m d square psi by dx square plus potential is they given, that is delta function potential a into delta x minus e. So we are substituted here psi equal to e psi. Now we want to integrate on both side from the limit because the center is a. Here the limit goes to a minus epsilon to a plus epsilon around the delta potential. We are integrating, it's a one dimensional potential, so it's pretty easy. A minus epsilon in plus integrate to a plus epsilon d square psi by dx square dot dx. This kinetic energy integrations plus a. Same way the limit a minus epsilon to a plus epsilon. The potential energy integrations equal to energy is constant, we can take it out. The psi of x a minus epsilon to a plus epsilon. Now this dot dx. Psi of x is continuous. That means psi of a minus epsilon should be equal to psi of a plus epsilon. The value of the wave function on the both side are equal, so right hand side goes to 0. Come to the next integration in the left hand side. A, we know the delta function property. In the integration of delta function x minus a, it will give the value of the function at x equal to e. Because the delta function will kill all other places. Only the wave function it will allow at x equal to e. That's why psi at x equal to a it will survey a into psi of a. The answer is now kinetic energy integration. It's straightforward. The integral of d square by dx square dot dx equal to d psi by dx. Lower limit a minus epsilon to a plus epsilon. The front term minus h square by 2m is as it is. So minus h square by 2m. This say d psi of a dx, it will go from here to here, but exactly at x equal to a, it will suffer the discontinuity. This value, so discontinuity at x equal to a is equal to, if we are moving to the right hand side, minus a psi of a. So discontinuity at x equal to a, so minus will be plus. So 2ma divided by h square psi of a. This is the final answer. So this much amount of value it will suffer the discontinuity for the given potential. So the option is 1.